black, white test or gap. You all know that lead was used by Romans to make the flatware. In my youth, we had a lot of lead pipes, and we had lead in the paint on houses, so they would rot in the winter, and then we had lead in gasoline. So lead has been used by human beings extensively, perhaps not to the benefit of the human race. Janet will talk to us about the effect on children in particular. Thank you, Janet.
Okay, thank you. So I'm sure everybody here has heard
sorry,
about...
she's the head of the economics department. I forgot to say that. She has a tough job.
Yeah, much rather be here than in my next couple of faculty meetings, but that's another story. Okay, so I assume everybody here has heard about the catastrophe in Flint with the lead leaching into the water pipes and potentially very negative consequences. So some of what I'm going to talk about today is directly relevant to that and understanding what we can expect. But I'm also, as you can see from the title, trying to sort of pull in some other things here. And specifically, one of the things that I've been very interested in is the environmental justice idea that we're not equally exposed to negative things like lead. And in particular, minorities and poor people tend to be more exposed, and then given that they're exposed, to have fewer resources to deal with the problems ex post. And we're seeing a little bit of that in Flint, you know, where you read the newspaper articles and people say, well, I'd really like to move, but I can't because now nobody will buy my house, so I'm trapped here. And so that happens on a much larger scale every day. So the questions that I'm interested in are, can environmental inequality explain any of the racial gap in test scores, which is another persistent social problem? As I just mentioned, African Americans are disproportionately exposed to pollutants. Conditional on exposure, they have fewer resources to counter the negative effects. Could be resources like being able to move, but even things like having a more nutritious diet can protect against things like lead to some extent. So if you're deficient in iron or deficient in zinc, then you take up the lead more, and it has a worse effect. So people with better diets would be less affected, conditional on exposure. And then a second question is, can environmental regulation therefore reduce disparities? And so I'm going to be talking about a specific program in Rhode Island that was introduced to remediate lead paint and seems to have been very effective in reducing lead levels in children in a very short period of time, and then show what consequence that had for their educational attainment. So the structure of this paper is first there's going to be actually quite a lot of descriptive material because there's background about lead, background about test scores, background about previous research on lead, sort of to be got through. Then I'm going to show you the specific disparities in lead levels by both race and income in Rhode Island. I'm going to tell you about this policy that was aimed at reducing the lead levels and show that it predominantly affected minorities and poor people. And then I'm going to try and link the disparities in lead levels with the declining disparities in test scores to try and establish a causal relationship. So this is where economists part company from other social scientists, and that we have the arrogance to claim that we're trying to identify a causal relationship, whereas other people just say, well, there's this correlation, but then act as if it's a causal relationship when they make policy recommendations. Okay, so relative to previous research, there's been a lot of research on lead, and so what are we trying to contribute? Well, a lot of those studies are basically correlational studies. Some of them are cohort-based, so things like studies of removing lead from gasoline will look at different cohorts who are affected. So one of the good things I think about our study is that we have repeated measures both of blood lead levels and also test scores for a large population that we're able to follow over time, so it's longitudinal. We have a plausible source of exogenous variation in lead, which was this policy that was introduced. And also, if you're particularly interested in lead remediation, I think that there are some lessons to be learned about policy interventions from thinking about this particular program. Okay, so the background literature that I'm going to go through, I'm going to talk a little bit about racial gaps in test scores. I'm going to talk about environmental justice, sources of lead in the environment, and effects of lead on young children, what we already think that we know about that. So, turning to racial gaps in test scores, this is another area where there's really a very huge literature. It's a very persistent social problem over time. Two volumes that I would particularly recommend to you are the ones by Jenks and Phillips and Magnuson and Wolfvogel. Those are both, collected volumes. And they talk about research about things like family income, family structure, parenting practices, quality of schools, school segregation, neighborhood segregation. And the bottom line seems to be, even if you try and account for all of those things, you still see some persistent gaps in test scores. But also those gaps in test scores are closing over time. So this is a picture of scores from the National Educational Assessment Program, which is, as it says, national. And so you can see that there's still a substantial gap in 2012, which is the last year of the graph, but it's about half the size of the gap in 1971. So something is happening to improve matters over time. And I think it's worth thinking about whether one of those things that's happening might be the environmental cleanup that's been going on in the US. So Jenks and Phillips say, well, given that these other things don't explain it, we should look for something else. I'm going to talk about one possible thing. Another interesting example is the paper by Shea, Gurian, and Mosander, which looks at health improvements in infant health for African Americans for the cohort affected by the civil rights movement. This is really an aside for what I'm talking about today, but it's a very interesting paper because what they show is that health improved really dramatically for the cohort that basically was enabled to use hospitals in the South because of the civil rights movement. So before 1964, there were a lot of segregated hospitals in the South. There were a lot of babies being born outside of hospitals. There were a lot of infants with things like diarrhea that died because they couldn't go to the hospital. And so the civil rights movement and the introduction of Medicare in particular said to hospitals, well, you cannot be reimbursed by Medicare if you practice segregation. And so overnight, all these hospitals were integrated. You saw a dramatic decline in infant mortality due to mostly preventable causes like diarrhea, pneumonia, and so on. So then that cohort, when they grow up, they have healthier children in turn. So there is this sort of intergenerational aspect to health improvement. The environmental justice literature, that's the name that's been given to this idea that African Americans and low-income families have a greater exposure to environmental toxins. And there's a lot of documentation that that's the case in the cross-section. Some work that I've done shows that even if you look at pretty small areas, like within a zip code, if there's some sort of hazard in that zip code, like a hazardous waste site or a factory that's emitting toxins, African Americans will tend to be living closer to that than whites in the same zip code. Okay? So there's lots of reasons why that might be the case. Some people argue that there's intentional citing of hazards in low-income or minority neighborhoods, maybe because those neighborhoods are less organized to resist citing those types of things. Another more market-driven explanation is just that it's because of housing prices. So if you're rich, you can afford to pay more for housing, so you can live in a place that has nice amenities and doesn't have environmental hazards. If you're poor, maybe you don't have that luxury. And then another thing that's being argued is that there's been disparity in the regulatory response to existing hazards, so that some laws, like say the law governing cleanup of Superfund sites, that sites that are close to wealthy people get cleaned out quicker than sites that are close to poor people. Okay, so in 1994, there was new federal regulation that was aimed at reducing the amount of this type of thing that went on. Some evaluations of that regulation have shown that, for example, if you look at Superfund sites, sites that are in areas with a high share of black families or poor families are still less likely to receive Superfund designation, but the good news is, conditional on getting designated as a Superfund site, there's no longer a disparity in the time that it takes to get cleaned up. So that evidence is kind of mixed. So I'm talking about a specific pollutant here, lead. So just a quick primer on lead. It has no biological value. It's toxic. The reason why it's toxic is because it mimics calcium in the body, and that calcium is involved in a lot of metabolic processes, so it interferes with renal function, endocrine function, cardiovascular function, and especially with the nervous system. So in the brain, lead has been shown to damage the prefrontal cortex, hippocampus, and cerebellum. I mentioned that nutrition affects rates of absorption. And children are particularly sensitive for lots of reasons. So one reason is that they're more likely to be exposed. If you have things like flaking paint and kids are crawling around on the floor and then putting their hand in their mouth, they eat the paint, which adults don't do very much. Conditional on exposure, the lead is more likely to be absorbed in children. And then conditional on absorption, it's more likely to affect the nervous system. So, for example, the blood-brain barrier is not functioning very well in very young children, so things pass more readily to the brain in children than they do in adults. And then once the lead is in the brain, you can't get rid of it. So, as I mentioned, there's a lot of research on this topic. We've known for centuries that high lead levels are associated with worse cognitive outcomes. So you have people like the Mad Hatter in Alice in Wonderland, right? Why were men? Oh, that was Mercury. I'm sorry, guys. Anyway, we have lots of examples of this. But the sort of really obvious examples are people who are subjected to high lead levels. And a lot of the recent focus, therefore, has been on the question of whether low levels of lead are dangerous. There's been some work using individual level data, doing things like linking preschool lead levels with test scores and behavioral outcomes, things like whether kids have ADHD or are aggressive. There's also a previous paper using data from Rhode Island that links preschool lead levels with kindergarten reading readiness. So just as a correlation, kids who have higher lead levels tend to have lower test scores. So, why isn't that enough? So there's two challenges that have also been widely recognized in the literature. So one is that because the kids who are more likely to be exposed are also more likely to have poorer families and less educated mothers and so on, for those reasons you would also expect them to have lower test scores. And so this quotation here is from one researcher who's done a lot of work on lead, just noting the fact that a lot of these correlations, if you control for even a few observable characteristics of families, will be much reduced. Okay, so we don't know exactly what the magnitude of this effect is. A second issue is that lead is measured using blood lead levels, but the lead doesn't stay in the blood. It gets deposited in the brain or the kidneys or whatever. And so then it's harder to detect. So it's often pretty imprecisely measured. Okay? So the first thing that I was just talking about, basically omitted variables, would cause you to overestimate the effect of lead. But this problem, just lousy measurement, would cause you to underestimate the effect of lead most of the time. So it leads to a lot of uncertainty about the size of the effect. As I mentioned, there's also cohort level analysis, particularly for things like getting rid of lead in gasoline. And I'll just show you a picture that kind of illustrates the issues with that. This is taken from Mother Jones, that well-known scientific periodical. But it's a very nice graph, I think, because it's showing the correlation between gas in lead and violent crimes. And you can see those things track really well up to 1979, where you start having a big decline in lead in gasoline. And then the reason why it says 2002 underneath is because the people who are affected in childhood, it takes some time for them to get to an age where they're committing violent crimes. Okay, so they track really well up to 1979, and then they start to diverge, right? So with these type of cohort analysis, you never really know, am I just seeing sort of coincidence that these two things happen to go together for a long time, and then that's going to fall apart, or am I really seeing a causal relationship? Okay, so historical sources of lead, mainly there's gasoline. In the 70s, a gallon of gas had 4 grams of lead. There's household paint. Some paint, depending on the color, had a really high lead content, up to 40%, especially before World War II. And then, as we've been hearing a lot, lead pipes, which were installed mainly in the late 19th and early 20th centuries. The weird thing about the pipes is that they remain lead pipes, but corrosion in the pipes tends to coat them with gunk that protects people from the effects of lead in the water. Right? So what went on in Flint is that they changed the source of water to something that was more corrosive, got rid of all the scale, so now the lead in the pipe can leach into the water again. But when those pipes were originally installed, they were shiny new, they were all leaching lead into the water. And there's some very interesting work in economic history looking at what happened when communities introduced lead pipes all over the United States. So I'm not going to talk about this, but if you're interested in that, I would recommend this book, which is very careful and actually kind of foreshadows what's going on in Flint, in the sense that his research design is to look at some communities that had hard water and some communities that had soft water. And in those communities, you would have the amount of scale in the pipes would be very different. And so then you could see differences in the outcomes in those communities before and after adoption of the lead pipes. Okay, so the regulatory response to this was in 1970, the U.S. Surgeon General issued the first formal statements about lead poisoning, saying that it was a national health problem. And since then, there's been 2 major regulatory changes. One was eliminating lead from gasoline, which was finished by 1996. And the second was eliminating lead from household paint, which was completely de-leaded by 1978. So what that means is that if you have a house that was built after 1978, it's not going to have any lead paint in it. But if you're looking at older housing, it's very often going to have at least some lead paint somewhere. This regulation seems to have been very effective. Lead in the air declined from 2.5 milligrams per deciliter in 1980 to less than 0.5 by 2012. And the percent of preschool children with lead levels over 10 declined from 8.6 in 1998 to 1.3% in 2004. And paradoxically, even though this is a great public health success story, I think it had the effect of taking everybody's focus away from that, because people thought, okay, now we've solved the problem, we don't have to worry about lead anymore. So is lead still a problem? One issue is that lead remains a hazard found in the soil, especially for many years. So it's estimated that 4.5 million households in the U.S. are still exposed to high levels of lead, and 500,000 preschool-aged children have elevated lead levels. And again, disadvantaged children are disproportionately affected. So the National Health and Nutrition Examination Survey, which takes blood levels and tests people for all sorts of things, shows that lead levels are 50% higher for African American children and 30% higher for low-income children. So we haven't reached the goal of eliminating elevated blood lead, which is the goal for the National Healthy People 2010, for the National 10-Year Objectives. And a lot of the recent focus has been on low lead levels, okay? So we really reduced the number of people with levels over 10, but what about people with levels of 5 or 4 or 3? Is that still going to affect people? And you can see the progress of the science kind of reflected in the regulation in the sense that the CDC used to be concerned with levels above 60, then they went to 10, then they went to 5, and now they say there is no threshold for concern. Any detectable level is of concern. Okay, so my data sources for this study are going to be data from the Rhode Island Department of Health, which are repeated child blood lead levels taken in the first 72 months of life. These have been linked to data on 3rd through 8th grade test scores, which are from the Rhode Island Department of Education. And that education data has a little bit of other information, like whether the child was in had an individual education plan, which would mean they had some kind of special education, or whether they had free lunch status, which is a marker for whether they're poor. And then the third source of data is the vital statistics data. Those are birth certificates, basically. And the reason we link to those is because the birth certificates have a lot of information about families, which is not in the other two sources of data. So they have information about race, which obviously is key here, and also mother's education, mother's marital status, birth weight, gender of the child, birth order, and so on. So we have all the data for all the kids born in Rhode Island from 1997 to 2004. A nice thing about Rhode Island for our purposes is that most children are screened. In a lot of places, kids are only screened if there's some reason to be concerned. So the number of people that are screened is very low. Here, 80% of kids are screened. That corresponds to basically all the kids that go to public schools. And so we end up with a final linked sample where we can link everything together of about 57,000 children, which is great for being able to see these relationships. A lot of these kids are going to be exposed through housing, and the program that we're going to be looking at is a program about cleaning up housing. So one marker is just, are you living in a house that was built before 1978? So nationally, 73% of African Americans are living in an old house, compared to 63% of whites. So there is a disparity there. And then within Rhode Island, the disparities are much greater. So if you look at the fraction of kids who are black, who are in pre-1978 housing, it's 83%, compared to 74% of whites. And then if you look by income, the disparities are much less, basically. Okay, so it's more about racial segregation than income segregation. This table is sort of showing the same thing. If I look within Providence in particular, Providence has a very high fraction of the poor black population in Rhode Island, 81%, compared to 11% in the rest of the state. So that's why this sort of targeted housing program could have such a big effect. Okay, so that's all the background. Now I'm going to set about just showing what the disparities are in both blood lead levels and test score levels. Okay, so in 1998, which is the first year of our data, if we just plot non-parametrically the distribution of blood lead levels and the distribution of reading scores for blacks and whites, you can see that there's some really big differences. Okay, so the black levels are shown in blue, the white levels are shown in red, and you can see that black kids were much more likely to have, say, blood lead levels over 5 than white kids. and that they also have lower reading scores to start off with. If you look by income, you see a similar pattern, not quite as pronounced. Okay. But as I said, one of the issues here is that some of this may be due to other, or some of the difference in test scores may be due to other confounders. So if you look at the correlation between blood lead levels and other characteristics of the family, kids with high lead levels have mothers who are less likely to be married at the time they were born, have younger mothers, are much more likely to have African American mothers, have mothers with less education, mothers with health risk factors like diabetes or hypertension. They're more likely to be poor, which is indicated by being always eligible for school lunch. They're higher birth orders, so they're in larger families, which is also associated with worse outcomes on average. So the lead remediation policy that I'm going to be talking about there were two policies. So the first part of the policy was implemented by the Housing Resources Commission and required all landlords to obtain a lead-safe certificate in order to rent out their homes. The policy was implemented in kind of a non-punitive way. So they were trying to cooperate with landlords and get them to have an incentive to participate in the program. So they provided a lot of training and information to landlords about lead abatement, like what's the lowest cost way to meet the standard. And the lowest cost way is often just to do something like fix flaking plaster and repaint. It's a lot cheaper than tearing out all the lead. They gave low-interest loans for landlords. They did not do much enforcement, although there was a threat of litigation. And they specifically targeted neighborhoods that they had the highest lead burdens. So those would be the oldest parts of the old cities and the ones with the greatest share of disadvantaged children. Okay, so this, did I lose my, there we go. The second part of the program was implemented by the Department of Health. This was slightly different because this was more reactive. So if a child had a elevated lead level in a building, then the landlord would be required to do some remediation and get a lead-free certificate. And if the landlord did not comply, then the state attorney general would file a suit against them. Okay, so this also resulted in a lot of lead remediation. Okay, so this is just showing the trends in the numbers of certificates. So you can see the program went from 0 to very active in a very short period of time. The program was also targeted, as I mentioned. So in this map, what I'm trying to show, the red areas are the areas that got the most certificates, and the white areas didn't get certificates. So you can see there's a lot of spatial variation. And then if you look at, as I mentioned, the thing was supposed to be targeted to the places that needed it most. So if you look at the number of certificates by the characteristic of the census tract, you see that places that had high average lead levels got more certificates. So just looking at whether those plots are sort of generally upward sloping. They had higher share black, they had a higher share poor, they had a higher share in pre-1997 housing. Now, if we look at what happened to the average preschool lead level by birth cohort, that shows this dramatic decline in a very short period. So from 1998 to 2004, we had the average level go from 4 to 2.5. And if we look at what's happening, compare the two cohort distributions, we can see the 1998 distribution was much higher than the 2004 distribution. So the whole distribution is shifting to the left. Looking at it by race, you can see that black children started with a much higher lead level than white children, and it declined more rapidly for black children than for white children. If I look by income, the declines for the high and low income, which is the school lunch and no school lunch groups, is kind of roughly parallel. So it's really showing that there was targeting by race. Okay, so I think the pictures show that there was this very rapid decline in lead levels, that it was greater for blacks than for whites. I'm asserting that that's because of the certificate program. A more formal way to look at that would be to estimate a statistical model with a whole bunch of controls. So that's what this is. I'm saying let's regress the blood lead level on the number of certificates per old home in your census tract, controlling for child characteristics, mother characteristics, characteristics of the census tract, like share poor, share black, and so on, the year of birth, and also a tract fixed effect. So this is looking within tract. So that's using only the timing of the program. So when I do that, sort of basically no matter how I try and measure the certificates, I see a negative and statistically significant correlation between the number of certificates and the blood lead levels. Okay, so this is showing I can use the Department of Health certificates only, I can use the Housing Resources Commission certificates only, I can use just the loans part of the program, and all of those things are associated with reductions in blood lead levels. Okay, in terms of the magnitudes, what this suggests is that the sort of average increase in DOH certificates reduced the average lead level by 0.36 units. And if you are at the large end of the spectrum in a really targeted neighborhood, you would reduce blood levels by 0.69 on average. Also, you can look within tract and say, were some kids more affected by this than others, even within tract? So even within a census tract, you could have a nice house that was gentrified and it's old, but it doesn't have any flaking paint, and right next to it you might have one with lots of flaking paint, right? So different people are living in those houses that even within the same tract, one might be more affected. So I'm trying to deal with that by putting in interactions with child characteristics. Okay, so here we have the baseline effect of the certificates at the top, then an interaction with whether the child is black, interactions with whether the child is on free lunch, interactions with maternal education, and also with whether the child is male. So the latter two things, there's no difference, but what those significant effects on the first two interactions are showing is that the program had a bigger effect for black kids and a bigger effect for poor kids. Okay, so so if you put this all together, I'm estimating that there was a 2.3 point decline in the average lead levels that was associated with the certificate program, and that accounts for about 21% of the decline in lead levels. Okay, so it's not everything, but it's a big chunk. Okay. So now I want to move on to talking about whether that had an effect on cognitive achievement. So what I'm going to do is I'm going to estimate models where I use the certificates as an instrumental variable for the decline in blood lead, and then I'm going to look at the effect of that decline on reading and math scores. I'm going to try and see whether it had different effects on different kids. Also look at the effects at third grade compared to the effects at eighth grade, and so on. So if I just plot out the lead levels by the test scores, you might say, well, you know, I don't need to estimate any models because this is really clear. Okay, so the first figure there is looking at the lead level versus the average reading score. And so you can see the higher the lead level, the lower the score. This one is doing the same for math. And then this is if the child had an IEP or special education program. Okay. So those all look good, but then this plot here is showing the mother's schooling and the average lead level. Okay? So clearly, the child's lead level could not have had any causal effect on maternal schooling, but this relationship looks very similar to these, right? So that kind of illustrates the problem of trying to make a causal statement here. Okay. So the instrumental variable strategy, the basic idea is that I'm going to first use the certificates to predict the decline in lead, which I've already showed you, and then I'm going to see how that predicted decline, which depends only on the certificates and not on all the other things, affects the test scores. Okay, so the method controls for potential confounding, that's the purpose of it. What it requires is an assumption that the neighborhoods that saw the certificates, that was the only important thing that was happening, that there wasn't some other systematic thing going on that independently had a big effect on child cognitive outcomes. Okay. The instrumental variables technique is also a method for dealing with measurement error. So I was saying there was a lot of measurement error in lead levels, so this will also help with that problem. So in terms of the assumption that I have to make that there isn't something else systematic going on, I'm trying to test that here by saying, okay, here's the certificate, and here's the change in the black population in the tract. Okay, so that's pretty centered on 0. It doesn't look like there was any systematic change in the racial composition of the tract. It doesn't look like there was any systematic change in the percent poor in the tract. Nothing going on really with median family income. And then the change in the housing prices, there is a change in housing prices over this period, right? It was the bubble running up to 2008. But again, it doesn't seem to be systematically related to the certificates. Okay, so when I do all of this and look at the relationship between lead and reading test scores, if I don't do the instrumental variables, I get this. Okay, so I get a negative relationship. It looks like it's statistically significant. It's not all that big. Okay. This is using, mostly what I'm going to use here is the average lead level. So for each child, I have 4 or 5 different blood draws. If I take the average, that also tends to mitigate the measurement error a little bit. If I just take one draw, okay, then I get a negative result, but it's a lot smaller. That's consistent with there being a lot of measurement error. Right? Now, if I do the instrumental variables estimate, I get a much larger estimate. Look at this by sort of sections of the distribution. So this is saying, did the child get a score that was below 30? So that's considered below proficient. If they got a score above 40, that's considered proficient. And if they get a score above 56, that's with distinction on this particular test. Okay? So you can see that it has a large effect on being judged below proficient. It has a significant negative effect on being proficient, but it doesn't have any significant effect on having distinction. Okay, so what that says is that the effect is really concentrated at the bottom of the distribution, that it's moving kids who are at the lower end of the distribution higher. If you look at math scores, something kind of similar. It has a positive effect on being below proficient, but no significant effect on the higher scores. And then if I look at changes over time, what you can see is that the effect in 3rd grade is large, but the effect in 8th grade is actually even larger, so it kind of accumulates over time. And that might be consistent with other literature in education talking about sort of cumulative disadvantage. If you get off on the wrong foot in school, then you tend to just get further and further behind. So it's not something that sort of is only there for young kids and then gets better. Okay, so we've tried to test these results in various ways. One is by using different measures of lead, because there is some variation in the literature. And another is by using different combinations of measures of this housing program. Okay, so here I'm showing different measures of lead. So you can do things like take out the really high measures. So when you're dealing with this kind of data, there's always a lot of like random typing errors. So if you see some kid with a measure of 500, it's probably wrong. Okay, so this is just taking those out. That doesn't really affect things. Another way is to use a more cumulative measure. Another is just to use the maximum, which is here. And then a lot of this literature uses a geometric mean, which tends to give us a slightly higher estimate. Okay? But all of those are giving a statistically significant effect. And then this table is showing along the top different estimates associated with different versions of this instrument, which are all down here. And again, we get really a remarkably consistent set of findings. We've also tried to tweak the model by worrying about whether there might be some trends going on other than these housing certificates. So here, we're putting in a separate trend for blacks and whites. Here, we're putting in separate trends for census tracts that have high lead levels to begin with. And here, we're just looking at the census tracts that have the highest lead levels in 1997. So if you were worried that there might just be regression to the mean, then if you just looked at the highest ones, then you might see smaller effects. But again, we find pretty consistent effects here, and then a larger effect in the most affected places. Okay, so the summary then is that there are these big racial disparities in lead levels and in test scores. We think that lead has a negative and causal effect on cognitive achievement that doesn't fade out over time. This policy had a differential effect on African American children because it had an important spatial component and because the African American children were the most at risk. And so in the very last part of the talk, I'm just going to try and relate the narrowing of the racial gap in lead levels to the narrowing of the racial gap in test scores. Okay, so if you look at this in pictures, this is showing the 1998 cohort, so I showed you this one earlier, and then the 2004 cohort. So you can see that the black distribution has really moved to the left. There's not much going on with the white distribution there, which I'll show you in a different picture in a minute. I also showed you this picture of reading scores, so this is just repeating that. Now, if I look at what's happening with reading scores, what you see is that the white scores distribution stayed basically the same, okay? And then the black one shifted to the right. Okay. So, two further exercises. One is to just calculate the share of the reduction in black-white test score gap that could be due to the reduction in lead levels. And to do this, I'm going to assume that the biological effect of lead on test scores doesn't vary much by race, which I haven't showed you that, but it doesn't seem to. And then I'm going to look at how the gap in lead levels relates to the gap in test scores. Okay, so the racial gap in test scores fell from 9.2 points for those born in 1998 to 6.3 for those born in 2004. So that's a decline of 70% to 45% of the standard deviation. That fell from 2.2 to 0.9 over the same period. So our estimates imply that the decline in lead levels explains about half of the decline in the test score gap. Okay, and if we do the same thing by income, the gaps in test scores and lead both fell, but by smaller amounts. And then if we try and regress one on the other, so now I'm doing a census tract level regression, so that's why I have so many fewer observations. And here is doing it at the county level, so then I only have 40 counties in Rhode Island. And so if I regress the gap in black-white reading scores on the gap in lead scores, point estimates are actually in the same ballpark as what I was showing before. The standard errors are much larger. Okay? So I can't prove statistically that those two things are related, but it seems reasonable to think so given the magnitudes. If I think about the cost effectiveness of this program, this was actually a really cheap program. So for all the cohorts that we study, it probably cost a total of about $4 million. The cost per child was about $679. And if our estimates are correct, it improved test scores by 0.12 standard deviations. So you can compare that to other types of interventions in the education literature. So for example, the Tennessee STAR experiment, which was an experiment to reduce class sizes, cost $8,000 per child and increased test scores by 0.2 standard deviations. So to conclude, Rhode Island implemented a policy that targeted and disproportionately reduced lead levels among African American children between 1998 and 2004, so in a very short period of time. The resulting decline can explain a substantial share of the decline in the racial test score gap. So I think the larger things that we can take away from that is that, well, from previous literature, it's been argued that eliminating the black-white test score gap would be the single most effective way to eliminate racial and economic inequality. You know, we could debate about that offline, but I think it's really important. And what this suggests is that if we continue to target environmental regulation to the children who are at the greatest risk, then that may ultimately lead to declines in future economic disparities. Yeah, I'm happy to answer questions. I've left them a little time.
Can you say something about the political dimensions, how the program got started, and what the impetus was, where it came from?
So I don't know as much about this as my colleagues in Rhode Island, but what I believe is that there was a report that talked about high levels of lead, and that led directly to this program. So it was some, a little bit like what's going on in Flint. There's some crisis, and then there's a response.
So changes in diet can also affect both the uptake and also diet response. So is it possible to do something about the possible changes of diet of people over the test? I mean, it's supposed to be the same point.
So, we actually tried looking into that a little bit because these N-Haynes data that I was talking about, they take blood levels, but they also measure serum levels of different vitamins and iron and so on. And we couldn't really see much going on in that level. So it is true. I mean, if you look at nutrition of American children, the thing actually that's kind of shocking is not disparities, but that everybody has such a terrible diet. So there's like lots of teenagers who don't eat any vegetables ever. And that's not actually as different as you might think by socioeconomic status.
First is, did I understand correctly that the declines came, or the increases that came at the lower end of the cognitive performance, but not at the higher end? So probably that is slightly puzzling in the sense that supposing we have a population with some probably distributed.
Just be louder, I think people can hear you.
If I have some trait like cognitive performance with some sort of normal distribution, if I went to such a population and decided to poison it, I might think that a small shift in the mean would have a much larger impact at the high end and not at the.
Yeah. So, but we're not like randomly deciding to poison people. We're only poisoning some people. That's kind of the point of. So like in Flint, right, people are saying, if this wasn't a poor black city, somebody would have done something and they wouldn't have just ignored us. And unfortunately, I think it's true, right? So that's really is what's happening. So the people in Flint get exposed to something for 5 months, and if it was in, Bel Air, that wouldn't have happened.
That's what I think. The thing is, I thought somehow that in your selection, you were looking ultimately at a sample where everybody was, is it the case that those whose test scores have not gone up were not part of the lead remediation, or they are also in the neighborhood with lead remediation?
So I guess what I was, so I don't know exactly who was subject to lead remediation. I only know where people lived, and I know that in this neighborhood there was a lot of lead remediation, right? But I guess what I was trying to say was that we know what these older neighborhoods that are gentrifying are like. You could have on the same block one house which had no lead problem at all because it was all got renovated, and then another house right beside it with significant lead paint problem. Right? And the people who were living in those houses would, other things being equal, probably have different test scores and probably be in different parts of the distribution. Right?
So then, ultimately, the idea is if you look at the test score and the idea is that the red is something that's eventually you're basically connecting. Would one look at the difference control and the other ratio that you could look at and get test score relative to what? So you try to make a derivative, which is to change the test score to that.
Yeah, what we're actually trying to do with this, we have a couple of other things that we're trying to look at. So, for example, lead in soil is different depending on how far away you are from a highway. And so we can measure that also. So I think what we're going to try and do is come up with different ways to measure potential lead exposure, and then hopefully show that all of those have similar effects on test scores.
More questions?
Going back to the green lead water pipe example, you said there's a huge difference between, or difference, whether or not they have hard water or soft water. So I'm guessing that soft water mitigates the lead, and if that's true, or maybe that's not true, would that make a difference in Flint, whether or not you have the soft system or the hard system?
Well, so-
Assuming that the pipe's old.
Yeah, actually, I could have this wrong because that wasn't my research, it's somebody else's research, but I believe hard water has lots of minerals in it. So hard water deposits scale in the pipe faster than soft water, so it would be the reverse of what you were saying.
Does that make a difference in Flint when they study that?
Well, in Flint, the issue is a little bit different. It's so the water from the Flint River is corrosive, and so it corroded all of the scale that was in the pipe, and then that allowed the metal in the pipe to leach into the water. And so apparently they were told very early on that there was a chemical that they should add to the water to make it less corrosive so that it wouldn't do that. And that advice was completely ignored. And the thing is that the same thing happened in Washington, D.C. a few years ago when they switched from putting chlorine in the water to putting, I think it's called chloralamines in the water, and that changes the acidity of the water. So the Washington, D.C. water, when they switched from chlorine to chloralamines, became more acid, and then did the same thing, took all the scale out, and then the lead starts leaching into the water again. So we already knew that the acidity of the water is important, and the people in Flint were actually told in advance that they should do something about that, and they didn't.
I was curious if you knew whether states other than Rhode Island adopted similar policies.
So that's a really good question, and I don't know that. I know that in a lot of places, like in New Jersey, they've sort of gone the opposite direction. They decided that, we have a budget problem and lead isn't a problem anymore, so we're just going to dismantle our lead programs. And I think that's unfortunately more common.
I'm wondering whether the certificate program applied to people who owned the homes that they lived in. Because it's interesting, and maybe
So I think that's a really good point, and these particular programs apply to renters, and lower income people are much more likely to rent than to own, right? So that's another reason why if rental properties are not well maintained, then people would be more subject to these problems.
Thank you, Kenneth, again.